Welcome you all in 16th lecture of Electronics Measurement and Instrumentation. In this lecture, I will discuss the spectrum analyzer and wave analyzers. So, in this lecture, this is the outline of my lecture. So, first I will discuss the electrical signal, analysis of electrical signal, different domain of electrical signal. Then what are the different equipments that we are using for the spectrum analysis, then type of spectrum analyzer and type of wave analyzer. So, electrical signal has basically we can analyze electrical signal in three domain, the time domain, frequency domain and modulation domain. Time domain basically when we are seeing the signal or we are analyzing the signal on CRO, cathode ray oscilloscope, then the signal is displayed in the time domain, means x axis is displaying the time and y axis is displaying the amplitude of the signal. Similarly, when we want to analyze a signal in frequency domain, then the x axis will display the frequency and the y axis will display the amplitude. In time domain, we are unable to analyze amplitude of a particular frequency. In frequency domain, we can analyze, we can segregate the frequency component and we can see the amplitude of a particular frequency component. Then similarly, in modulation domain, we can see the change in frequency and we can see the modulation accuracy, etc. We can also check the modulation index and different behavior of the modulated signal. So, as seen in as we can see in figure, in spectrum in frequency domain analysis, frequency spectrum analyzer is used. In time domain analysis, oscillator is used, and for the modulation domain analysis, modulation analyzer is used. This is the signal. Suppose we are having three frequency components or three signals which has different frequencies, and we want to analyze, we want to see the signal on the CRO screen. So, on the CRO screen, this type of signal waveform we will get. We can also see the signal, sum of the signal or the difference of the signal on the CRO screen, but it is in the time domain. So, in time domain, we are unable to analyze what is the amplitude of a particular frequency signal, that is suppose F1 or F2. Now, when we use it in the frequency domain or we use spectrum analyzer, then we can see the amplitude of that particular frequency. Suppose a signal F1 is having an amplitude of this one. So, in spectrum analyzer, this type of waveform we will get. So, here the amplitude of the signal whose frequency is F1 is displayed separately. Similarly, F2 and F3 are displayed separately. So, in frequency domain analysis, we can see the signal amplitude of any frequency component that is present in the signal. So, these are the different instruments that we are using for the measurement purpose. The power meter is used for the measurement of amplitude, and this power meter basically measure the accurate total power measurement. In frequency counter, we can measure the frequency, and this is used for the very accurate measurement of the frequency. Similarly, the RF spectrum analyzer is used for the measurement of frequency as well as the amplitude measurement also. Similarly, RF vector network analyzer, by which we can use the RF properties of the RF device, and it also measures the frequency and the amplitude of the signal. But and in this RF vector analyzer, we can also, it also provides the information about the impedance of the ports. So, what is a spectrum analysis? A spectrum analysis is the study of energy distribution of a signal as a function of frequency. So, in frequency domain and the time domain analysis, so we can change the time domain signal into frequency domain and frequency domain into time domain by just applying a mathematical derivations. So, here we can see that this is the signal, the time domain signal. Suppose this is a continuous wave. So, if we see it this signal on a CRO, then it will be seen like this way. But if we want to see this signal, we want to analyze the spectrum of the signal, means what is at what frequency it is producing the amplitude, then frequency domain analysis is done. Similarly, there is FM signal. So, the FM signal spectrum is like this way. We have if amplitude modulated signal. So, we know that at amplitude modulated signal there is a carrier frequency and then there is a side bands. So, carrier frequency amplitude is shown here and the amplitude of the modulating signals are here, side bands are here. So, in frequency domain analysis we can analyze the spectrum of the signal, what frequency the signal is producing, what are the fundamental frequency, what is the amplitude of the fundamental frequency, and then what is the amplitude of the harmonics, because every signal produces a fundamental frequency and the harmonics. So, we can analyze the signal amplitude of a frequency range by spectrum analysis. So, there are so many equipments used for the spectrum analysis like superheterodyne spectrum analyzer, where we are using IF amplifier, and then fast Fourier transform spectrum analyzer. So, in FFT spectrum analyzer, basically the incoming signal is converted into digital signal by sampling, and the successive sampling is passed through the FFT processor. The FFT processor provides all the signal processing, so that spectrum analysis information can be passed through the controller and it is displayed on the screen. So, but the problem with the FFT spectrum analyzer is that the spectrum, if FFT spectrum analyzer, sometimes we are not able to see the signal spectrum when the signal is in transient phase. So, transient signals are we are not able, we can miss the transient signal when we are using FFT spectrum analyzer. So, real time spectrum analyzers are used. So, here what we do, we just in real time spectrum analyzer, the analysis of RF signal is driven and the process is like overlapping of the different signals. So, when the signals are overlapping, then we can also identify the glitches or the any type of the noise signal is there. Then there is one more spectrum analyzer, that is USB spectrum analyzer. So, in USB spectrum analyzer, basically the signal is converted into digital form and it is stored in the specially designed FPGA, and then that FPGA we can carry and we can analyze the signal on the computer or any place. So, now is a spectrum analyzer. So, spectrum analyzer is a device that measures the amplitude of an input signal versus frequency within the full frequency range of the instrument. It represents the energy distribution of a signal as a function of frequency graphically. The amplitude, so spectrum analyzer is a form of, here we are using a CRT and it is a form of CRO. We can say in CRO the x axis represent the time signal, time period, and here the x axis represent the frequency range. In spectrum analyzer, since the spectrum of the signal is analyzed, so this signal may have a carrier frequency, it may have a noise signal. So, there is a large variation in the amplitude of the signal. So, to get that frequency, to represent the amplitude of the signal on the screen, we use logarithmic scale. So, y axis is generally using a logarithmic scale. In x axis, in frequency axis, we can use logarithmic scale or we can use normal scale. So, in frequency domain analysis, complex signals are separated into their frequency component and the level of each frequency can be displayed. So, in this it reduces the amount of noise present in the signal, and this spectrum analyzer is very much used in the designing, implementation, testing, maintenance of the RF circuits like the wireless circuit and other circuits, the microwave circuits. So, these spectrum analyzers are used to analyze these if there is any fault or any problem is there. So, now we will discuss the type of spectrum analyzer. So, there are two type of spectrum analyzer, one is frequency, one is filter bank spectrum analyzer, another is superheterodyne spectrum analyzer. in filter bank spectrum analyzer, as shown in figure, there is a band of filters, and these band of filters, they have pass band, they are pass band type of filters, and these filters have very sharp very sharp bandwidth, very narrow bandwidth, and these filters are having some different cutoff frequency, and these filters bandwidth is overlapping to each other, so that no frequency component can be all the frequency component can be seen on the screen. So, suppose we want to measure a frequency of signal which is having many frequency, but we want to analyze a signal frequency from 0 to suppose 150 kilohertz. So, the filter which has a cutoff frequency of 150 kilohertz, that filter is selected, and that filter will pass the input signal, and other filters are not will not pass the input signal. So, input signal is passed through that particular filter which has a cutoff frequency of the same 150 kilohertz, and then that signal is passed through that filter, and then there is a detector circuit. The detector circuit basically convert the AC signal into DC signal, and that DC signal is fed to the vertical plates, vertical deflection plate of the CRO. This is the CRO screen. So, in the CRO screen, the Y plate, the Y deflection plate is used for the amplitude display, and the X plates are used for the time display. So, the time signal, the ramp generator signal is fed to the X plate. These are the X plate which are placed vertically, and these are the Y plate which are placed horizontally. So, ramp signal, we know that the ramp signal generates this type of frequency, this type of signal. This is the trace period from suppose this and this. So, this position is the extreme left of the CRO. The extreme left position is this, and this is extreme right position of the CRO screen. So, this frequency, suppose 0 to 150 kilohertz we want to display. So, 0 to 150 kilohertz, this whole screen of the CRO is divided equally between 0 to 150 kilohertz. So, this ramp generator basically display the frequency on the screen. There is an electronic switch. So, that electronic switch will select that particular filter and detector circuit for which we want to measure the frequency range, and then it is displayed on the screen. Then next is superheterodyne spectrum analyzer. In superheterodyne spectrum analyzer, as we see in the figure, the input signal is applied to the RF input attenuator circuit. This spectrum analyzer is used for the measurement of signal in the radio frequency range. So, in this range, suppose we want to see the spectrum of any particular range of frequency, then the input signal is passed through this spectrum analyzer circuit, and this spectrum analyzer equipment used a RF input attenuator. So, this RF input attenuator basically select the amplitude of the signal. If the amplitude of signal is very high, then we can reduce the amplitude of the signal by selecting the RF input attenuator position. So, a knob is provided, and this knob is a multiplier circuit. So, it will multiply the signal, the input signal, and we can select the range of the signal. Because in superheterodyne spectrum analyzer, the signal amplitude, because there is a noise signal and there is some signal which has very high amplitude. So, all the signal, if suppose frequency we want to analyze, and at that frequency there is a very low amplitude signal and a very high amplitude signal. So, we want to analyze both the signal. So, for this purpose we are using the RF input attenuator, and in this spectrum analyzer also we are using the Y scale in the form of logarithmic scale, because the amplitude variation is very high. So, that input signal is passed through the RF input attenuator, and it get attenuated if required. Then it is passed through the low pass filter. The low pass filter is the filter circuit which passes the signal, it has a cutoff frequency that is desired for the that particular input signal. So, it passes the signal to the mixer circuit. What is the function of mixer circuit? Mixer circuit function is to add and subtract the signals. So, it has two input, one is the input signal, input is there, and second is the input from the local oscillator is there. So, suppose if input signal we can represent by Fs and this we can represent by Fl. So, this mixer will produce sum and difference of these two signal, means it will produce Fs plus Fl and Fl minus Fs. So, this whether Fs plus Fl or Fl minus Fs, both the signal is passed to the IF amplifier. So, this mixer is the basic function of this mixer is to produce the sum and difference of the frequencies of the signal which is applied to them. Then there is an IF amplifier. The gain of the IF amplifier we can vary. There is a knob provided for the variation of this input signal. This IF gain of the IF amplifier, and this IF amplifier has a very fixed band. We can say it passes only a fixed band of frequency for which we have to select it. So, if suppose we have selected IF amplifier for suppose 0 to 100 kilohertz. So, suppose we have selected 0 to 100 kilohertz, only this signal will pass to the IF amplifier, and then if it is required it will be attenuated or it will pass to the IF filter circuit. So, again IF filter circuit will pass only this range of frequency, and then it is applied to the log amplifier, because because variation is very high. So, we need log amplifier. Normal amplifier is unable to amplify the large amplitude variation. So, log amplifiers are used. After the log amplifier, when the signal is amplified, then it is fed to the envelope detector. So, envelope detector's basic function is to convert AC into DC, because we want to display the signal on the screen. So, that signal is passed, so it is this envelope detector converts the signal into video form, video range, and then that signal is applied to the display circuit. Here is one more circuit, that is one is a reference oscillator that produces a signal, then there is a local oscillator. Local oscillator is generally voltage tuned oscillator, VTO. So, voltage tuned oscillator means it is the frequency range of this this oscillator depends on the sweep generator's output, because the sweep generator's output is fed to the this local oscillator circuit, and it is also fed to the display circuit. So, in the display circuit it is fed to the X plate of the CRO, and here it is fed to the local oscillator frequency. So, reference oscillator will produce a frequency, but that frequency is controlled by the local oscillator and it is controlled by the sweep generator. So, suppose we want this 0 to 100 kilohertz signal is we want to display on the screen. So, what will the screen this is suppose RAM signal. So, here to here the total display will be 100 kilohertz, and suppose this local oscillator is producing a signal from 100 kilohertz to 200 kilohertz. So, suppose it is 100 kilohertz to 200 kilohertz. So, and this IF filter has a band of 100, it will only pass the frequency which has 100 kilohertz frequency. So, that signal is passed through IF filter which has 100 kilohertz frequency. So, what will happen, suppose we want to measure 0 to 100 kilohertz frequency, and here this sweep generator is controlling the frequency of the local oscillator, and local oscillator frequency is controlled like 100 kilohertz to 200 kilohertz. So, what will happen, suppose the signal of 0 kilohertz is applied, and at that time the electron beam which is on the CRO screen at 0 position. So, what it will produce, the mixer circuit will produce 0, 100 kilohertz minus 0 and 100 plus 0. So, it will provide 100 minus 0, it means that signal is displayed on the leftmost position of the CRO. Next, suppose this signal is, suppose this 0 signal, suppose electron beam is here mid of this CRO. So, mid of this means suppose it is at 150 kilohertz. So, it is at 150 kilohertz and 0 signal is passed over there. So, what will happen, 150 minus 0, 150 plus 0. So, it will produce the output of 150. So, 150 kilohertz is not passed through IF filter circuit. So, it means it is not displayed on the screen. So, what will displayed on the screen here 100 to 200 kilohertz and the mid of this will represent 150 kilohertz. So, suppose a signal of 50 kilohertz when the electron beam is at the mid position and the signal of 50 kilohertz appears. So, what will happen, this 150 plus 50 and 150 minus 50. So, 150 plus 50 it will produce 200 kilohertz. So, that signal is not passed through the IF filter circuit. Then the next is 150 minus 50, then it is passed through the 150 minus 50, then it is 100 kilohertz and that 100 kilohertz will pass through the IF filter. So, the 50 kilohertz frequency is displayed at the center of the screen. So, this type of filter, this screen will display the respective frequency component on the screen. Although the X plate of this CRO is fed with the sweep generator, but sweep generator is not displaying the time domain of the signal, it is displaying the signal in the frequency domain. So, it will select like the frequency that will pass through the IF filter circuit and that is displayed on the screen. So, screen will display the spectrum of the frequency components. So, this is the working. Low pass filter will allow only the frequency component that is less than the cutoff frequency and mixer gets the input from low and high frequency. Then these are the application of spectrum analyzer. The deviation frequency, it is used for the spectral purity of the continuous waveform. We can measure the percentage of modulation percentage. Then it can also measure the electromagnetic interference or electromagnetic measurement if we require. And so, we can analyze any type of spectrum, any type of signal by this spectrum analyzer. So, now next is wave analyzer. Spectrum analyzer gives the spectrum of a signal. We can analyze the spectrum of the signal, we can see the signal behavior at a particular frequency range. But what is a spectrum analyzer? Spectrum analyzer only represent the amplitude of the signal at a particular frequency. So, if we want to measure the frequency, suppose we want to measure the frequency of the fundamental frequency component, then we can select that particular frequency. So, there is a knob, by that knob we select the particular frequency and it will measure the amplitude of that frequency in either in the term of dB or in the term of simple voltage. So, the basic function of the spectrum analyzer is there is a primary detector circuit. So, detector input is fed to the detector circuit will detect, it is basically LC filter. So, L and C combination will select the particular frequency. We know that cutoff frequency f is equal to 1 by 2 pi root LC. So, by this it will select the input the frequency whose analysis we want to do, and that component of frequency, that signal is passed to the full wave rectifier, and the full wave rectifier converts AC into DC and it will give the average value of the signal which we have applied. Then there is a PMMC galvanometer instrument, and that instrument can be calibrated in terms of peak amplitude. So, it can display the peak amplitude, although the amplitude that is applied by the full wave rectifier is the average, but we can calibrate it in terms of peak value. So, this is the basic circuit of superheterodyne wave analyzer. There are two type of wave analyzer. The first one is superheterodyne wave analyzer. In superheterodyne wave analyzer, again the input signal is fed to the input attenuator circuit, and input attenuator circuit by which we can control the amplitude of the signal. Then it is fed to the amplifier circuit, which amplifies the signal. And suppose we want to this wave analyzer is having a frequency range of 0 to 18 megahertz. So, 0 to 18 megahertz signal is passed over there. Then suppose we want to analyze the frequency of we want to see the amplitude of the signal whose frequency is 18 megahertz. So, that is passed. So, there is a local oscillator, we will select the frequency. Suppose we have selected the 18 megahertz frequency, then it will produce 30 to 48 megahertz frequency, and the mixer will again produce the sum and difference of the signal. Then the difference signal is passed by the IF amplifier, because its range is 30 megahertz, it will pass only the signal of 30 megahertz. Then 30 megahertz signal is passed to the second mixer, and then second mixer there is a crystal oscillator. We know that the crystal oscillator produces the maximum stable frequency. So, here the crystal oscillator is used and it is producing 30 megahertz frequency. So, 30 this mixer has two inputs, one is 30 megahertz, one is having 30 megahertz, and other the input signal is also having the 30 megahertz frequency. So, it will produce 0 frequency. So, 0 frequency component is passed to the low pass filter, active low pass filter, and then that this signal which has now 0 frequency is displayed by the detector circuit. It is detected by the detector circuit, and this is simply a voltmeter, and this voltmeter will display it into volt or dB. So, this is the function of filter. Now, there is one more wave analyzer, that is frequency selective wave analyzer. So, frequency selective wave analyzers are used for again the display of signals single frequency component. So, when we want to display amplitude, we want to measure the amplitude of a single frequency, then we are using wave analyzer. So, in wave analyzer the input signal is again fed to the input attenuator circuit. So, attenuator circuit will attenuate the signal if required, if not required then it will fed to the high Q filter. So, there is a filter circuit L and the combination of R and C, and the C is basically we can use the range, and by changing C we can change the frequency by 10 times, and then between that 10 times we can vary the frequency by using the R, by varying the R. There is a driver amplifier. The driver amplifier's function is to isolate this filter circuit from the input circuit, so that this filter circuit will not affect the performance of the input circuit, input signal, and similarly the input circuit will not this input circuit will not get the performance of the this high Q circuit. Then it is fed to the attenuator circuit. So, it will select the meter range frequency, whatever the range of the meter, that the amplitude is selected by this filter. Then it is amplified by the output amplifier. Then it is fed to the meter amplifier and detector circuit, and then detector circuit will display detector circuit, basically it will convert AC into DC, and then it is measured by the voltmeter. And if it is required to display at any screen, suppose we want to display it on the computer screen, then it is fed to the auxiliary output for the secondary device. So, that is all. I have discussed two type of one is wave analyzer and there is spectrum analyzer in this lecture.